Hello and welcome to the first of hopefully many video podcasts describing some of the weather products and ocean data that exist in WeatherNet and our GRIB Explorer for the iPad software. Podcasts will look at each type of weather content, discuss some of its history, and in some cases how to interpret and process it. But we'll also look at how to acquire it with WeatherNet or a GE iPad, and then how to use it within some of our other affiliated software such as GRIB Explorer. These aren't going to be terribly fancy or anything you'd see on the Oscars, but we're hoping that they'll give you insights into some of these rather unique data sets and how to benefit from them. First of the products we're going to take a look at is something called ASCAT Satellite Wind Scatterometer. Some people call it ASCAT. I'm going to go in here now and quickly grab an ASCAT file from WeatherNet, starting in WeatherNet's portal page. I've got this red box showing the area of the world that I want to pull ASCAT data for, and then I've got the ASCAT data selected over here in the data window. Don't worry about how we got this far. We'll go back and review that later on. But right away, I'm going to go hit download now, and then go. The data will come flowing in. When I'm done, I see the transfer done message. I punch this little close transfer window, and WeatherNet now will look for GRIB Explorer, launch GRIB Explorer, and display that. So here we're looking at an ASCAT Scatterometer wind file for the Northeast Pacific. So, scatterometry, what the heck is scatterometry? These are actually ocean winds measured by a satellite, downloaded to a ground station, processed into GRIB data, and then pulled by us to our ever-on weather servers. They're exceptionally unique data sets. Really nothing else like them in the world. Unlike any of the other GRIB wind products, or I should say most of the other GRIB wind products, scatterometer winds are not modeled winds. These are the actual winds on the ocean surface that at the time the ASCAT satellite flew over the ocean. It's almost like having an individual ocean buoy measuring wind data out there for each one of these data points. A little bit of history. ASCAT's predecessor in the early 2000s was QuickScat. OCENS and our GRIB Explorer software was one of the few means of viewing QuickScat data at that time, and we received a fair amount of anecdotal commentary on the data. One of these came from the Vendée Global racers that were running at that time. They in fact found the QuickScat data so accurate, so reliable, that they actually used it to assess when they should set their spinnakers during the race. It's pretty amazing. Because they're measured, not modeled winds, ASCAT data are not only an excellent source of wind data in and of themselves, they can provide a real handy means for you to evaluate the accuracy of some of the wind data coming from the GRIB models. Download an ASCAT file like this for the North Pacific, compare it to a WaveWatch 3 or a GFS or a NavGem file, and see how they're doing. Are these models overestimating or underestimating the winds? Are the projected wind shifts that you're seeing through space similar to what you're seeing here in the real data collected by ASCAT? We'll do a little bit of that later on in the blog. So as you can see, the ASCAT data are unconventional, maybe even a bit peculiar. The satellites scan and collect information in these swaths, which I'm moving my cursor up and down one of the swaths. There are some key elements of these swaths. First of all, you'll note that each swath has a different time. watch over here on the right hand side in this area as I move my swath, or move my cursor from one swath to the next. So this one was collected at 818 UTC. The next one to the east was a little before, 724. And then we see 630, and so on. This happens because, of course, the Earth is turning as the satellite is going around it from north to south or south to north. Each satellite orbit then gets slightly offset from the one before it, and through the time the satellite tracks itself across the globe. Gaps, these gaps down here between swaths exist for a couple of reasons. Nothing is scanned directly under the satellite. There's basically a gap there. And then the field of view of the satellite, the area that it actually is scanning, isn't wide enough to overlap from one orbit to the next at the low to mid latitudes. As the satellites converge toward the poles, we get almost complete coverage. And you see that up here. Generally 45 to 50 degrees in farther north or farther south, you have darn near complete coverage of the wind field. The other thing about time in the swaths is it's also changing within a given swath. As I move the cursor up and down in this far west swath, you'll see that down here to the bottom it's starting at about 8:15, and as I move north, 8:16, 8:18, 8:19, and so forth. You get the picture. If time is increasing as I'm moving from bottom to top, obviously I'm in an ascending pass. I'm in a pass moving from south to north, the satellite scanning from south to north. And the obvious is always also true. That is, if time is increasing as I go from north to south, I'm in a descending pass. Any analytical importance to that? Not really. But time itself does have analytical importance. Always be aware of the time of the ASCAT swath, or the piece of the ASCAT swath at which you're looking. It takes about 3 hours for the satellite to collect the data, relay it to the ground station, process it, and then make it publicly available so we can pull it to our servers. So the very best ASCAT data you can look at is about 3 hours old. If the area of the ocean you're interested in is not the subject of a specific orbit, then it'll be older still. So when comparing your wind speeds in the ASCAT data to the wind speeds in your GFS model, be sure you're comparing the data to the correct step, the time step of that GFS model. Now what about this time date stamp down here in the lower part of the image? This is the time when the file containing the data you are looking at was created. So you'll never find data, actual ASCAT wind measurements, in the field of view up here that is newer than the time stamped down below. Remember, if you're looking at it in GRIB Explorer like we are here, and you've told GRIB Explorer that you want to look at all of your data in local time, then that time will be offset from the Greenwich or Universal Time, and you'll see the local time value down here. So WeatherNet gives you, and GRIB Explorer delays for you, 30 of the most recent orbits of ASCAT data. If you were looking at the whole globe in GRIB Explorer, which you probably wouldn't do because of the size of the file, you would see 30 different orbits, the 30 most recent orbits. And secondly, GRIB Explorer always displays the most recent orbit, or the most recent data on top. That's why you see in some of these areas like here, this ascending orbit laying over the top of these pieces of the descending one. Descending one's going up this way, actually coming down this way. So we had a descending orbit. One of the last 30 orbits was this descending orbit here. But then, since that descending orbit came by, we've had an ascending and newer orbit occur here. So GRIB Explorer calculates that difference and then plots the data, the most recent data, on top. So what looks like a hodgepodge of swaths going this way and that in this picture really do follow some pretty clear rules. That is, you're always looking at the 30 most recent orbits. If there's data from these 30 orbits in your field of view or in the area you're interested in, it's going to be plotted. The most current data is always plotted on top, and time distance differences exist in the data from orbit to orbit and north to south, south to north within the orbit. What else is noteworthy? So let's look at the colors here. The colors in the swaths represent wind speeds. These speeds can then be compared to your little palette over here on the right hand side to give you, just from a color perspective, a gross picture of where your wind field lays out. Like obviously we see this yellow, pale greens, I guess, up in here in the central Gulf of Alaska that are, in the 40s, 30s, upper 30s wind speeds, whereas down here toward Hawaii, see the dark blues and some low, very low, under 10 knot wind speed. So color gives you a really quick way of identifying where the higher or lower winds might be. We've talked a little bit about the properties bar already. That's this guy over here on the left. It's hard to show it here because when I move over there with my cursor, obviously I'm leaving the field and the pertinent data. But you're going to see time information, speed, direction information, and the position of the cursor and the distance from where your quote boat is, which in this case our boat is somewhere on the U.S. East Coast. The other thing that you see there in the properties bar is something called rain, yes or no. I am going to try and zoom in and see if we have any rain flags in this picture. Yeah, here we go. So you see that most of these wind barbs are exactly as you're accustomed to seeing wind barbs. Except look at this little guy right here. Rain confuses the ASCAT sensors. Confusion is bad because it makes the sensor think the wind is one speed when it's actually another. So what the ASCAT data processors do is flag a wind measurement when they think it might be contaminated by rainfall. And they put these little boxes at the base of the wind barb on those contaminated values. Now this one looks pretty consistent with everything around it. Probably not a real issue, probably just an odd data point. But you'll notice that when I move my cursor over that wind barb, my rain value changes to yes. So that's how GRIB Explorer demonstrates to you. If you see a bunch of these rain barbs in a given area, then it's cause for some conservative use of data from that area. In general, though, it's very uncommon to see an extensive field of rain contaminated data. That processing has improved dramatically over the years. I'm going to move up here and then click on the fit to height to move us back to the screen image of the entire North Pacific. And I'm going to show you something called the horizontal profiler, which is this little icon here. Two things happen when I punch that. Obviously, one is this little graph that appears. That graph is showing me wind speed and the vertical versus the distance along the arc of this red line that you also see in the screen. By default, we plot this red line from the lower left to the upper right corner of your screen. But I can grab either end of that line with my mouse and slide it to any location and grab the other end, do the same thing. And now I can almost use it as a radar. I can use it to scan across this field of wind data and get a quick eye at what actually are the speeds of the data in that field. So I've got a spike here somewhere. You see this spike in wind. Now I want to find out actually where is that spike along the course of that transect. To do that, I can just move into my graph, point at the spike, and see, boom, it's right there. Then I can go over here. I'm just going to close this and roughly zoom. I'm going to grab my region zoom tool. I'm going to move my cursor up and to the left of that area, drag down and to the right, and zoom right on that. And indeed, here we see some really high speeds, 44 knots up in there. 50 knots. 53 knots. So that's an area of pretty intense wind action. And then look, here we've got a set of, quote, rain-contaminated wind information we want to be a little careful of. Obviously, you can use the profiler for other reasons. Click back to fit to height. Maybe you're looking at a transect or a run line that you want to look at between points A and B. You can set start of the line on where the boat is, and then draw the line out and get an idea for how wind is laying out over that period of location. All right, let's go back to WeatherNet now. This time, I want to add another layer. We talked earlier about how you can use ASCAT to kind of evaluate your GRIB model data. Let's do that here and see what happens. To do it the easiest way I find it, because I want to actually smash the ASCAT data together with the GRIB model data, is to go into library mode. The library mode is, for lack of better words, it's the full WeatherNet library. It has all of the details. So you can get into a great level, a great degree of specificity. I've created an ASCAT folder earlier. You'll see that here. And in that folder, I've drug in from my wind wave category the ASCAT information, which is going to tell me, just grab it and drag it down. It's going to tell me it's already there. And I have drugged some WaveWatch 3 data, some wind data. Let's grab a 4-day file. I'm going to just grab that and drag it down here. Okay. So now, let's see. Okay, it's already in there. Now we have WW3, WaveWatch 3 data, a 4-day forecast of that, along with ASCAT. And I'm going to tell WeatherNet that I want to download these GRIBs and smash them into a file, one file. And I do that down here in the GRIB combiner. A little bit of an aside, WeatherNet GRIB Explorer follow a couple of rules. If data is from a different models, we don't automatically layer them on top of one another because we want the user to be very conscious of the fact that they are different models, or in this case, different sources. But we can override that feature with the GRIB combiner here, which is what I've done now. So I'm going to go ahead and now download the 4-day wave watch and the ASCAT data. I want to check my map just to make sure that I'm pulling in roughly the same area, which it looks like I am. And then I punch the go button. Oops. This is live. So I forgot to put a little green arrow on my ASCAT folder, so it didn't know that indeed I wanted to pull stuff from there. Go ahead and go. All right, transfer is done. Now I'm closing. And there we see in one file, here's the file name up here. In this picture, here's our first screen, our first time slot for the WW3. And then, boom, there is the ASCAT data, very similar to the one we were just looking at. So, now let's do a little bit of a side-by-side. So we have ASCAT data, which was collected at 1700 UTC, processed at 1700 UTC. And then we have this WW3 data set that was, here's the time frame for the 18 UTC. So let's compare the data we have in here to the data we have in the ASCAT. Let's pick a data point. We're seeing, let's pick 45 north, and this is 150 west. And we are seeing wind speeds of about 27 knots in the GFS model. So 45 north, 150 west. Let's go back and see what we have in the ASCAT model at the same time. 45 north, 150 west. We have 15 knots of wind. That was at what time? You'll see, look over at the properties bar, 7 o'clock this morning, 7 o'clock UTC this morning. So roughly 11 hours different than the 18 UTC run. So let's go back and look at what the 12 UTC run shows us. Here we're looking at 45 north and 150. So the 12th UTC time slot says 28.7 for that same location. 45 north, 150 west, so it's 15 knots. So either case, either side of this, the ASCAT data seems to be measuring wind speeds which are quite a bit lower than the wind speeds forecast by the WW3 model for that same location. Yes, here we're 4 hours different. Been fun to have one more earlier run of the GRIB model for the, say, the 6 a.m. time. And you would probably get that if you were, keeping an eye on weather. If you were crossing the Gulf of Alaska, you'd be updating regular to be able to see that. But this is not a bad example. ASCAT's showing us data that's informing us a little differently than what we might expect just from the model. What's happening out there in reality is showing wind speeds a little slower, in some cases maybe a lot slower or a lot lower than the wind speeds we're seeing in the GRIB model. All right, so now let's go back and show you how we can actually find ASCAT data in WeatherNet. We've already done it here in the library mode in a very quick fashion. Let me just be a little more deliberate this time. Let's create a new batch. Let's call it ASCAT number 2. I'm going to leave all of my defaults as they are. That is, I want to use GRIB Explorer to look at the GRIB data. And then I hit OK. Now I'll see ASCAT 2 down here on my list. The ASCAT information is located in the GRIB in the library. This is our main library section over here. Everything from buoy data to weather charts, including lots and lots of GRIB information. ASCAT's in the GRIB wind wave section, has its own little category in there, and then wind. You see the little OCENS logo? That means that's the actual file that you've decided I want to get that data. So to get that, I grab it and I pull it down into my ASCAT number 2, right over the top of my ASCAT number 2. Or, as I also want to get some WW3 information, I can grab that, and likewise I could just pull it over the top of the folder name, or I can grab it straight down into this big area, this detail section that lives at the bottom of the screen. So that's it. I want to grab the data, I want to get some ASCAT data, I want to compare it to WW3. Now I slide up to my little download arrow, click that, takes me over here to the transfer, and then from the library mode, you're adjusting your map location at this step. Well, let's be a little more interesting. Let's see what ASCAT's doing in the Atlantic. I'm going to change my view of the world by clicking the Change Views icon button. And let's draw a big box around the Atlantic. I press OK. And then go. I do like to bring in big chunks of the ocean when I'm working with ASCAT information. But that does suggest that you want to take a look at these data while you still have a high-speed connection. When you are offshore, maybe running on a lower speed Iridium or Global Star phone, you'll probably choose a smaller chunk of the ocean. It's downloaded. Let's put it in here, and there we are. We grabbed a couple extra pieces. So we've got the WW3 wind, and then there's our ASCAT data. Pretty straightforward. Create your folder, find the files in the library that you want to put in that folder, and drag them from the library into your folder. How about doing that in portal mode? Portal mode is probably the more commonly used approach. We can certainly do the same thing there, but we use our little launch wizard to do that. I can either punch the launch wizard and start at the very beginning, or I can go directly to one of these icons at the top that are different types of data. This icon in the very left is all of our GRIB weather data. Click on that. I select wind, obviously. And the important thing to remember when I'm looking for ASCAT data is I have to select the one-day forecast. Because ASCAT data is only observed data, it's not forecasting out 2 or 3 or 4 days. So if I change this from 1 day to 2 or more days, the next step you won't see the ASCAT as an option for you. I'll stick with 1 day when I'm looking for ASCAT data. Click Finish. And now we have this tree unwind itself over here on the left-hand side. It shows popular, shows our GRIB met, and here's our GRIB wind wave. And there's our ASCAT information displayed there. It'll come in originally like that is unchecked. You'll tell it that I want the ASCAT and I want the WW3 global data by simply clicking on those boxes and putting a check mark in them. And then now I'll go and grab an area of the South Pacific over here off of Western South America. Grab some ASCAT data and WW3 information for that. Let's do something a little different. Instead of doing WW3, let's grab some GFS. Let's do GFS global here for this one. So I've told it I want GFS for the model data and ASCAT data for the wind data from the ASCAT Scatterometer. Press download and again go. And click close transfer when it's all done. And there it is. And there's your GFS data. So we now can find ASCAT information for the South Pacific, North Pacific, Atlantic, Indian Ocean. It's available for the entire globe in any of the world oceans. I'll next show you how we can get to the same data, but using our GRIB Explorer Plus app that is based off of the iPad. Alright, here's our GRIB Explorer for the iPad app. Double clicking on the icon. GRIB Explorer loads itself into a pretty plain vanilla main screen. But then if you look down toward the bottom of the screen, you see 4 links or 4 buttons down there. I'm going to tap on the one that says Select GRIBs. I'm going to choose the connection method, the communication method that I want to use. In this case, I want on the network here, but you can see we have a whole range of options for all of your satellite devices, many of them with our Sidecat satellite Wi-Fi router. Done there. I'm going to leave forecast duration at 1 day. Just like in WeatherNet, ASCAT data is only available for 1 day, so I don't want to change it to any of the other values, otherwise I won't see ASCAT as an option for myself. The map. Click on Select from Map. I can see a similar big red box. I can move that anywhere in the world. Where haven't we been? Let's drag the screen over, and then I move my finger into the middle of the box and then pull it over to the South Atlantic. Move to 1 or more corners, and I can make that box size bigger or smaller. Just leave it right there. When I'm done, I move to the top of the screen and hit done again. Actually picking the GRIBs, go to Select GRIBs. I choose ocean wind. That's real important. Obviously it's not surface pressure, but it's also not global wind. We don't want global wind. We want the ocean wind category. And then press done. And then for my data source, tap on data source and check the scatterometer value. When that's done, I tap that as well. Alright, I'm now going to download ASCAT data for the Southern Atlantic through my network connection. I do that by tapping the download button here up top. GRIB Explorer Plus sends the request out to the servers, pulls it back, flips the screen, and then processes the data and displays it for you. I'm going to use the pinch process, 2 fingers, one in the upper right, thumb in the lower left, and just pinch together to see the to unzoom the product, and then grab my little finger here and move it around to look at the different values of the data in the image. Same sort of thing, you've got your swaths, you've got your gaps that we talked about, you've got your overlapping coverage at higher latitudes, and over here even you've got a nice set of rain flags. Let's go and pinch and expand out. See the rain flags on those guys there. Pinch and drag it back together again. We have the tools for Explorer iPad, like we had there, showed you as the horizontal profiler in WeatherNet. Here we call it the route finder, but similar sort of objective. We're using an A to B line, and we see the graph of wind speed in the vertical, distance from A on the way to B in the horizontal, and then above the graph we see the actual direction of the wind in these points along the line. And it's as simple as that. That's pretty much how it works. You've got a palette there with your winds. You have all the detail at the point of the cursor. You have your graphing and zooming tools, and then a very easy way to grab that data in the Select GRIBs section. So that just about wraps it up. Thanks for listening. I hope this was helpful. We will do another little video very shortly dealing with one of our other very unique products in WeatherNet and GRIB Explorer Plus for the iPad. Thank you very much.